Hi students, now we'll talk about section 3.5, which is relative velocity, but I will start with relative velocity in one dimension, in x direction or in y direction or something like that. Let us understand this concept by doing this example. If we have a bus and we have the road and we have the ground and a person on the ground and a person inside the bus, we need to understand the problem. If we have each thing from these things is moving with a velocity. For the person on the ground, its velocity is v1 because its number is 1. The ground is numbered as 0, so its velocity is 0. Its velocity is v0, but I need to find the reference at the beginning. So my reference in general, it's the ground. So the velocity of the ground, which is named or numbered by 0, with respect to itself, which is v00, or v ground with respect to ground, is equal to 0 meters per second. The velocity of the person on the ground who is walking, for example, or maybe he is standing, and his velocity with respect to ground is v10. Maybe he is standing and at stationary and his velocity is 0 with respect to ground. But in my example, I suppose that v10 is equal to plus 6, means I will move to positive x as positive, negative x as negative sign. Now his motion with respect to ground with velocity plus 6 meters per second. What is the velocity for the ground with respect to ground? It is 0. What is the velocity for the man with respect to itself? I mean v11. It is equal to 0 meters per second. We can find that. What the velocity of the ground v0 with respect to 1, with respect to this man? If the man moves in this direction with velocity positive 6, then the ground seems to move with respect to man with velocity negative 6. So if we change the indices, then we need to change the reference points, and then we need to change the direction or the signal of the sign of the argument. Okay, for the bus, I named it 2, and its velocity is v2. Its velocity with respect to ground, which is the reference, is v20. Its velocity to the negative x-axis in our representation. Then I give it a magnitude 10 meters per second, but because it is in negative x direction, I give it a minus sign. So v2 with respect to ground, v20, is equal to negative 10. What is the velocity of the ground with respect to bus? It is v02. V the ground with respect to the bus, it will be positive 10, not negative. So anyone the ground sees the bus moving with velocity negative 10. The bus seeing the ground moving with positive 10 meters per second. So if we are sitting in a car and the car moving to east, and if we look at the ground outside the car, we will see it moves to the west with the same velocity. East and west, positive and negative, the same velocity, 10 and 10. Now if we have a person moving inside the bus walking, for example, to the positive x direction. This person named 3. Its velocity v3. But his velocity with respect to bus v3 too. He is moving now inside the bus with velocity positive 3 with respect to the bus. What is the velocity of the bus with respect to that person? It is negative 3. So the person see the body of the bus, which the person inside the bus, moving in the opposite direction with the same velocity. So this should not be weird when we solve numerical examples. Now, if I need to find V2, 1. V2, 2 is the bus. 1 is the person. Okay? I need to find the velocity of the bus with respect to person who is moving with velocity 6. Maybe he is running. Now, I need to jump between the known velocities. I know the velocity between the bus and the ground, and I know the velocity between the ground and the person. So I can jump between these references. I can't find it directly, the velocity of the bus with respect to person. So I need to find V2 with respect to 1 is equal to V2 with respect to ground plus V ground with respect to person. So I need to find V2 0 then plus V0 1. V2 0 is negative 10. V0 1 negative 6, the velocity of the ground with respect to person. Then the total velocity will be negative 16. So the person sees the bus moving to the negative x direction with negative 16 meters per second. If you look to the indices, I need F2, 1. So I find, look at these indices here. I have 2, 0, 0, 1. If you hide the zeros, you will find 2, 1. I have 2, 1. I start with 2, end with 1. I start with 2, end with 1 in the right hand side. Let us look at another example. I need V3 to 0. 3 is the person who is moving inside the bus. I need his velocity with respect to 0, which is the ground. Okay, I don't know it directly, so I need to jump between the known references. V3 is known with respect to 2, to the bus, and V bus is known with respect to ground. So I can move in this way. So V3 0 is equal to V3 2, which is known, plus V2 0. V3 with respect to bus is positive 3, plus V, the bus with respect to ground, is negative 10. So I have plus 3, negative 10, which is negative 7. So the velocity of the person who is walking inside the bus with respect to ground is negative 6. It's negative 7. Negative 7 means he is moving to the negative x direction. Now the bus moving with velocity 10 and the person moving with respect to the right with velocity 3. So I have 10 and I have the person moving with 3. This is minus 10. The total velocity or the resultant velocity, it will be negative 7 if we add these two vectors together. Again, look at the indices. I start with 3 and with 0, then I will start with 3 and end again with 0. 2 will be disappeared at the end. Now the longest one. What is the velocity of the person moving inside the bus with respect to the person who is running on the ground? I don't know it this velocity directly, I need to jump between these references. I will move from this one to the bus, to the ground, then to the person who is running. Okay, I need to find V3 with respect to 1. I know V3 2, I know V2 0, I know V0 1. V3 2, the person walking inside the bus in the positive x-axis with 3 meters per second. Also V2 0, the bus is moving with negative direction 10 meters per second. V0 1, the velocity of the ground with respect to the person on the ground running is negative 6. Then the resultant velocity between the resultant velocity for the person inside the bus with respect to this one is negative. This one sees this one moving to the negative direction, but 13 meters per second. Again, look at the indices. I need V3 with 1. I start V3 2, V2 0, V0 1. 2 will go with 2, 0 would go with 0. I start with 3, end with 1. This is the relative velocity in one dimension. I will move in the next part to the relative velocity in 2 or 3 dimensions.